bar graphs. And the data set that we're going to use as an example is the Titanic data set. So here we're interested in survival, whether or not you survived. So 0 is that you're not alive, you died. And 1 is that yes, you did survive, you are alive. Okay. A bar plot shows, in this instance, probabilities. So I have a bar plot of the probability of survival by gender. Okay. Um, in this instance, we have a categorical input, which is gender, men and women, and a categorical output, which is if you survived or if you died. And I produce a numeric, which is the survival probability or survival rate. I calculate this probability with this code here, which subsets the data, and then uses the formula for uh, observational probability. The total number who survived, that are men, divided by the total number of men. And the same for women. So this is an example of observational probability in action and being graphed. So we can see here that the survival rate for men is only 20%, whereas for women it's somewhere above 70%. Okay. So based on this graph, the question that's being asked is, does gender, does that affect your probability of survival? That is, if you're a man, do you have the same chances as surviving the Titanic as a woman? And here, based on this graph, it does not appear to be the case. Um, So the conclusions from this bar graph is that it suggests the probability of survival is different for men versus women on the Titanic. An important thing to consider when you're making conclusions is to consider how the data is collected. And that concerns the design of the experiment. So the data is a designed experiment. If we can randomly assign people to inputs or groups, the data is observational. If you're just observing the data, no, you're not attempting to assign the data or the individuals to a group. So in this instance, it's not possible to assign the passengers of the Titanic to the group of men versus women. Like, I can't make someone be a man and someone else be a woman. And, in addition, all these passengers are dead. Um, or, you know, most of them. So this type of data is observational. In terms of tests of hypotheses, the researcher wonders if the probability of survival is different for men versus women. And whenever you're asked about a test of hypotheses, you have what's called a null hypothesis, and that's always a statement of no effect or equality. So in this case, um, the gender does not affect the probability of survival. Or in terms of equality, the null would be the probability of survival is the same for men versus women. The alternative is a statement of an effect or um, or inequality. So for inequality, it would be the probability of survival is not the same as the probability of survival for men. It's not the same as the probability of survival for women. And in terms of no effect, it's that, excuse me, in terms of statement of an effect, it's that gender does affect the probability of survival. Okay. Since since this data is observational, we cannot claim causation. Any conclusions are simply correlations or associations. Thank you very much.